Picture this. You're standing on a chunk of rock that's hurtling through space at about 2,288 miles per hour. The ground beneath your feet is um, technically a piece of Earth that got punched into orbit by something the size of Mars. And the wild part, that thing you're standing on is slowly sneaking away from us. Right now, as you read this, about an inch and a half every year. That's the moon, our moon. And here's the thing, almost everything you think you know about it is either incomplete, oversimplified, or flat out wrong. Let me see. Where do I even start with this? Because the story of the moon isn't really a story about a rock. It's a story about a cosmic car crash. A 4.5 billion year old corpse. Ancient humans who built entire religions around it. A Cold War pissing contest that somehow ended with golf on another world. And a brewing land grab that's about to make the California gold rush look like a polite tea party. And the craziest fact? We're closer to building permanent moon colonies right now than we were to landing on it in 1960. Like by orders of magnitude. By the time we get to the end of this video, you'll understand why some of the smartest people on Earth are betting their entire careers and billions of dollars that the next great civilization won't be on Earth at all. But before we get to lunar real estate and the trillion-dollar industry nobody's talking about, we need to go back. Way back. To a time when Earth didn't even have a moon. And what happened next kind of broke physics. So anyway, let's get into it. About 4.5 billion years ago, Earth was a teenager. And like most teenagers, it was a hot mess. Literally. The surface was a churning ocean of magma. The atmosphere was basically toxic steam. And the whole planet was getting bombarded by leftover debris from the solar system's chaotic formation. Not a fun place to be. But here's where it gets interesting. Earth wasn't alone in its orbital neighborhood. There was another planet, a whole separate world about the size of Mars that astronomers have named Theia, named after the Greek goddess who was, fittingly, the mother of the moon. The naming part actually came later, but stick with me. Theia was minding its own business, doing its little orbital dance around the sun, and then somehow the math broke. Whether it was gravitational interference from Jupiter or some other rogue body that nudged Theia just slightly off course, we don't really know for sure. But what we do know is that Theia and Earth were on a collision course, and there was nothing either of them could do about it. Now, when most people imagine this, they picture two planets smashing together like billiard balls. That's not what happened. The impact was a glancing blow. Theia hit Earth at an angle at roughly 9,000 miles per hour. To put that in perspective, that's about 4 times faster than a rifle bullet. Except the bullet is a planet. The energy released by that collision was, kind of hard to wrap your head around. We're talking about something on the order of 10 to the 33rd joules of energy. For comparison, the asteroid that killed the dinosaurs released about 10 to the 23rd joules. So this impact was roughly 10 billion times more energetic than the one that wiped out the dinosaurs. Just sit with that for a second. The collision vaporized most of Theia. It melted a huge chunk of Earth. And it flung an enormous cloud of molten rock and vapor into orbit around our planet. For a while, Earth had rings, like Saturn, except the rings were made of liquefied planet. Here's a fact most people don't know. Within about 100 years, that ring of debris coalesced into the moon. Not millions of years, not even thousands. About a century. Gravity is like ridiculously efficient when you give it enough raw material to work with. And here's an open loop I want to plant for later. Because it matters. When that debris formed the moon, it formed extremely close to Earth. We're talking about 10 times closer than the moon is today, which means the early moon, as seen from Earth's surface, would have been roughly 10 times bigger in the sky. Picture a moon that takes up nearly your entire field of vision when you look up. That's what our ancestors, the first single-celled organisms, would have seen if they had eyes. Wait, that's not even the wildest part. We'll get to the wildest part in just a bit, because what the moon did to early Earth is the only reason you're alive, right now. Without the moon, complex life almost certainly doesn't exist, and I'll explain why in detail soon. Now, this giant impact hypothesis, as it's called, wasn't always the leading theory. For most of human history, people had all kinds of weird ideas about where the moon came from. Some thought it was a piece of Earth that just spun off due to centrifugal force. That was actually proposed by Charles Darwin's son, George Darwin, in the late 1800s. He was a mathematician and astronomer, and his theory was that Earth used to spin so fast that a blob of it just flew off and became the moon. Other scientists thought the moon formed somewhere else in the solar system and got captured by Earth's gravity. This is called the capture hypothesis. And then there was the co-formation idea, where Earth and the moon just formed together side by side from the same dust cloud. All three of these theories were popular at various points, and all three of them turned out to be wrong, or at least mostly wrong. The thing that finally settled the debate? The Apollo missions. When astronauts brought back actual moon rocks, scientists were able to analyze their isotopic composition, and what they found was kind of mind-blowing. Moon rocks have almost the exact same isotopic signature as Earth rocks, like suspiciously identical. That ruled out the capture theory, because if the moon formed somewhere else, it would have a different signature. But the rocks were also slightly different in their volatile content, which ruled out simple co-formation. The giant impact hypothesis was the only one that fit. The moon is made of Earth and Theia, mixed together and melted into a new world. By the way, here's an obscure fact that blew my mind when I first learned it. Some scientists now think Theia's core might have sunk into Earth's core during the impact. So when you walk around on the ground, the iron in the planet beneath your feet might literally contain pieces of another world. A world that doesn't exist anymore except as part of us. Kind of poetic when you think about it. Anyway, let's keep moving. So we've got our newly formed moon sitting really close to Earth, glowing red hot. What happens next is, in my opinion, the most underrated event in the history of life on Earth. The moon started backing away, slowly, and it took the energy of Earth's rotation with it. When the moon first formed, Earth was spinning fast, like really fast. A day on early Earth was about 6 hours long. Yeah, 6. The sun would rise, you'd have just enough time to get a coffee, and it would already be setting. Sleeping in didn't exist. But the moon's gravity was pulling on Earth's oceans, creating tides. And those tides were creating friction. Friction with the seafloor, friction with the coastlines, friction with itself. And friction always does the same thing. It robs you of kinetic energy and converts it into heat. So Earth was losing rotational energy. And here's where the physics gets cool. Energy can't just disappear. Conservation of momentum and all that. So where was it going? It was going into the moon. The moon was getting a little energy boost from every tide, every wave, every drop of water that sloshed around on Earth. And that energy was pushing the moon further away. Right now, the moon is moving away from Earth at about 3.8 centimeters per year. That's roughly the rate your fingernails grow. Doesn't sound like much, but over billions of years, those centimeters add up. The moon has moved from about 22,500 kilometers away at formation to about 384,000 kilometers away today. That's a lot of fingernail growth. Here's the deal, though. This wasn't just a cosmic curiosity. This moon-Earth dance is what made complex life possible. And I promised I'd explain why. So here we go. The moon stabilizes Earth's axial tilt. Right now, Earth tilts at about 23.5 degrees. That tilt is why we have seasons. It's why some places get hot and cold, why crops grow at certain times of year, why ecosystems function the way they do. Without the moon, that tilt would wobble. A lot. We're talking variations of like 0 degrees to 90 degrees over millions of years. Imagine living on a planet where every few 100,000 years, the entire climate system just resets, where one hemisphere is in eternal night for tens of thousands of years, where the poles flip-flop with the equator. That's what Earth would look like without the moon. Mars, for instance, has tiny moons that don't do much. And Mars's axial tilt is wildly unstable. It's swung between about 13 degrees and over 60 degrees throughout its history, which is one of many reasons Mars is a frozen wasteland and Earth has, redwood forests and dolphins. Ultimately, the moon is the reason your ancestors evolved at all. Every fish that crawled onto land, every dinosaur that roamed, every mammal that survived the asteroid, every human that ever existed, they all owe their existence to that one cosmic car wreck 4.5 billion years ago. And here's the thing that gets me. The moon is still moving away. Eventually, in about 50 billion years, if Earth and the moon both survive that long, they would become tidally locked. Earth would always show the same face to the moon, the way the moon always shows the same face to us. Days would be over a month long. Of course, the sun's going to swallow us both before that happens, so it's a hypothetical. But still, kind of haunting to think about. Speaking of the moon always showing the same face, let me get to that because there's a juicy mystery there that wasn't solved until pretty recently. And what's on the other side of the moon is, well, let's just say it's not what anyone expected. Okay, so here's something almost nobody thinks about. The moon has a near side and a far side. Not a dark side, by the way. That's a common misconception. The far side gets just as much sunlight as the near side. They take turns. It's just that we never see the far side from Earth because the moon is tidally locked to us. Tidal locking happens when one body's rotation slows down so much that it ends up rotating at exactly the same rate as it orbits its partner. So the moon rotates once every 27.3 days, and it orbits Earth once every 27.3 days. The math works out so that the same side is always facing us, forever. For all of human history until 1959, no human eye had ever seen the far side of the moon. Think about that. Hundreds of thousands of years of humans staring up at the sky, and we'd only ever seen half of our nearest celestial neighbor. It was like having a roommate you've lived with for a decade, and you've only ever seen the left side of their face. In October 1959, the Soviet Union sent a probe called Luna 3 around the moon. It took 29 grainy photographs of the far side, and when scientists developed those photos, they were genuinely confused. The far side of the moon looks nothing like the near side. The near side, the one we see, has these big dark patches called Maria. That's Latin for seas. Early astronomers thought they were oceans, hence the name. They're actually huge basins of ancient solidified lava. They're dark because the basalt rock is darker than the surrounding lunar highlands. The near side is, the face of the man in the moon. It's smooth in places with these big dark eyes and a kind of crooked smile. The far side has almost no Maria. Like less than 1% of its surface is covered by these lava plains, compared to about 31% on the near side. Instead, the far side is just cratered, heavily, intensely cratered. It looks more like a typical airless moon, bumpy, scarred, ancient. Why? Why are the two sides so different? This puzzled scientists for decades. The leading theory now is that the near side has a thinner crust than the far side. The near side crust is about 60 kilometers thick, while the far side is closer to 100 kilometers. So when ancient asteroid impacts cracked the crust, it was easier for magma to seep up through the near side. That magma flooded the impact basins and created the Maria we see today. The far side's thicker crust held the magma in. But that just raises another question. Why is the near side crust thinner? And here's where it gets weird. One hypothesis proposed in 2011 suggests that Earth used to have two moons. Yeah, like a big one and a little one. The little one was about a third the size of the big one. And at some point they collided, not in a violent explosion, more like a slow motion cosmic pancake. The smaller moon kind of splattered onto the far side of the bigger moon, depositing extra crust material. That's what made the far side thicker and more mountainous. Is this true? Honestly, we don't know. It's a hypothesis. But it does fit the data better than most alternatives. And it would mean that at one point in Earth's distant past, our planet had two moons in the sky, which is just like an insane mental image. Here's another obscure fact for you. The far side of the moon is also home to the largest impact crater in the entire solar system. It's called the South Pole Aitken Basin. It's about 2,500 kilometers wide and 13 kilometers deep. To put that in perspective, that's bigger than the entire continental United States from coast to coast. And it's so deep that if you stood at the bottom and looked up, the rim would be below the horizon. You'd just see a vast bowl of darkness extending in every direction. What hit the moon to create that crater is still being debated. Some scientists think it might have been a dwarf planet-sized object. Whatever it was, it left a permanent scar on the far side that we're still studying today. And here's the thing about the far side that ties into our future. Because it always faces away from Earth, the far side is the quietest place in our entire region of the solar system, radio-wise. There's no Earth chatter, no radio stations, no TV signals, no satellite traffic. It's a radio dead zone, which makes it the perfect location for the most ambitious telescope humanity could ever build. And we'll get back to that, I promise. But first, let's talk about how humans figured out what the moon even was. Because before we had probes and astronauts, our ancestors had to make sense of this glowing thing in the sky. And the stories they came up with, some of them are surprisingly accurate. Others are completely bonkers. For most of human history, the moon wasn't a rock. It was a god, or a goddess, or a hunter, or a rabbit, or a frog, or in some cases, a literal mirror that showed the souls of the dead. Let me think about how to even cover this, because every culture had its own moon mythology, and most of them are fascinating. But there are a few that really stand out. The ancient Mesopotamians who lived in what's now Iraq worshipped a moon god named Sin. Not to be confused with, sinning. Sin was actually one of the most important gods in their pantheon. They believed he rode across the sky in a boat. And here's a wild detail. The Mesopotamians were tracking the moon's movement so precisely that they could predict lunar eclipses centuries before anyone else. They had records going back over 1,000 years. The Egyptians had Thoth and Khonsu, both associated with the moon and with time. Khonsu's name actually means traveler, referring to the moon's journey across the sky. The Egyptians used a lunar calendar for religious ceremonies and a solar calendar for daily life. They were basically running two timekeeping systems at once. In Chinese mythology, the moon is associated with the goddess Chang'e. The story goes that she drank an immortality potion and floated up to the moon, where she's lived ever since with a jade rabbit who makes the elixir of immortality. By the way, China named their lunar exploration program Chang'e in honor of this myth. So when you see headlines about Chang'e 5 or Chang'e 6 missions, that's where the name comes from. The Aztecs believed the moon was the goddess Coyolxauhqui, who was dismembered by her brother. They saw the dark patches on the moon as her broken body parts. A bit dark, but, that's mythology for you. And here's one I find genuinely funny. In some Norse mythology, the moon was being chased across the sky by a wolf named Hati. And at the end of the world, during Ragnarok, the wolf would finally catch the moon and eat it. The Vikings were just out here casually mythologizing apocalyptic cosmic events. Here's a fact that I think doesn't get enough attention. Almost every ancient culture independently figured out that the moon affects the tides. Long before anyone understood gravity, before Newton, before anyone could explain it mathematically, people just noticed the pattern. High tide, low tide, moon overhead, moon below. They didn't know why, but they knew the relationship was real. That's a testament to how observant our ancestors were. The ancient Greeks were the ones who really started to figure out the moon scientifically. A guy named Aristarchus of Samos, around 270 BC, actually calculated the distance to the moon. His math was off, but the method was sound. He used the shadow of Earth on the moon during a lunar eclipse to estimate the size of the moon relative to Earth, and then used parallax to estimate distance. The guy was doing astrophysics before anyone had even invented the word. And then there's Hipparchus. Around 150 BC, this dude calculated the moon's distance with an accuracy of about 26%, with no telescope, no computers, just geometry and naked eye observations. The actual average distance is about 384,400 kilometers, and Hipparchus came up with something like 480,000 kilometers. That's embarrassingly close for someone working with sticks and shadows. For comparison, when I was in school, I remember learning about these ancient astronomers and just kind of brushing past them. Like, oh, cute, the Greeks did some math. But when you actually look at what they were doing with the tools they had, it's genuinely insane. These were the original data scientists. They had no equipment, no peer-reviewed journals, no calculators, just a notebook, the sky, and a lot of patience. Then came the Dark Ages, and a lot of this knowledge got, kind of lost in Europe. But the Islamic world preserved it. Astronomers like al-Battani and Ibn al-Haytham were studying the moon's motion and properties during a period when most of Europe wasn't doing much science at all. Ibn al-Haytham in particular wrote a treatise called On the Light of the Moon around 1000 AD. He correctly figured out that the moon doesn't generate its own light, that it reflects sunlight, which was at the time kind of a radical idea. Fast forward to 1609. Galileo Galilei points his newly improved telescope at the moon, and what he sees changes everything. Galileo realized the moon wasn't a perfect, smooth, heavenly sphere as the church taught. It had mountains, valleys, craters. It looked, in his words, like Earth, just dead and gray and silent. He drew the first detailed maps of the moon, including the major maria and craters, and by doing so, he essentially destroyed the Aristotelian view of the cosmos, which held that everything above Earth was perfect and unchanging. This got him in some trouble, as you might know. The Catholic Church wasn't a fan of his ideas, but the cat was out of the bag. Once people could look through a telescope and see the moon was a world, not a god, the entire relationship between humans and space started to shift. For the next 350 years, astronomers mapped the moon in increasing detail. They named the craters after famous scientists and philosophers. They tracked its motion to incredible precision, but they couldn't actually go there. That changed in the most absurd way possible. Because of all things, a political fight between two superpowers who couldn't agree on, well, anything. So anyway, let's talk about the space race. Because the story of how humans actually got to the moon is way weirder than you probably remember. October 4th, 1957, the Soviet Union launches Sputnik 1, a 184-pound metal sphere with 4 antennas. And the United States loses its absolute mind. Here's the thing, Sputnik wasn't actually a military threat. It was a beeping ball. It went around the Earth every 96 minutes, broadcasting a radio signal that anyone with a basic ham radio setup could pick up. That was it. That was the whole satellite. But Americans interpreted it as proof that the Soviets had won some kind of cosmic chess match. If they could put a satellite in orbit, they could probably drop a nuclear bomb anywhere on Earth. The panic was kind of intense. Schools started cramming math and science into curriculums overnight. The government created NASA in 1958, specifically to catch up with the Russians. And then it got worse. In 1961, the Soviets put the first human in space, Yuri Gagarin, a 27-year-old Air Force pilot from a peasant family. He orbited Earth once in a flight that lasted just under 2 hours, and he landed by parachuting out of his capsule, which is something they didn't tell the international community at the time because it would have invalidated the flight under aviation rules. That's an obscure fact most people don't know. Gagarin didn't land in his spacecraft. He ejected at about 7 kilometers altitude and parachuted to the ground. The Soviets lied about this for years to make sure his flight counted as the first complete human spaceflight. President Kennedy, sitting in the White House, looked at all this and decided the US needed a moonshot. Literally. In May 1961, he stood before Congress and committed the United States to landing a man on the moon and returning him safely before the end of the decade. At the time, this was insane. The US had like 15 minutes of total spaceflight experience. The longest American mission so far had been a 15-minute suborbital hop by Alan Shepard. And Kennedy was saying, yeah, we're going to send people to the moon in 9 years. To put the scale of this in perspective, NASA's budget at its peak during the Apollo program was about 4.4% of the entire US federal budget. Today, NASA gets about 0.4%. So at the height of Apollo, NASA was getting roughly 10 times more proportionally than it does now. We're talking, in modern dollars, hundreds of billions spent on the program. By some estimates, Apollo cost about $280 billion in today's money. And it almost didn't happen. In January 1967, 3 astronauts, Gus Grissom, Ed White, and Roger Chaffee, were killed in a fire during a routine ground test of the Apollo 1 capsule. The fire happened because NASA had filled the capsule with pure oxygen at high pressure, which is, in retrospect, an insane decision. A single spark turned the capsule into an inferno. They died in about 30 seconds. The program got delayed by almost 2 years while NASA redesigned everything. And here's a detail that gets me. The reason NASA used pure oxygen in the first place was to save weight. A pure oxygen atmosphere at lower pressure could use thinner cabin walls than a mixed atmosphere at higher pressure. They were optimizing for weight, and 3 men paid for it with their lives. After the redesign, Apollo started flying again. Apollo 7, Apollo 8, Apollo 9, Apollo 10, each one pushing closer to a landing. And then, July 16, 1969. A Saturn V rocket lifted off from Kennedy Space Center. On top of it sat Neil Armstrong, Buzz Aldrin, and Michael Collins. The Saturn V, by the way, is still the most powerful rocket ever successfully flown. It generated 7.6 million pounds of thrust. The new SpaceX Starship is more powerful in raw thrust, but as of right now, it hasn't proven itself the way Saturn V did. Saturn V had a 100% success rate across 13 flights. That's bonkers for a vehicle that complex. 4 days later, on July 20th, the lunar module Eagle descended toward the moon's surface. And here's a detail that doesn't get enough attention. During the descent, the onboard computer started throwing error messages, 1201 and 1202 alarms. Armstrong and Aldrin had no idea what they meant. They had to trust mission control to tell them whether to continue or abort. A 24-year-old guidance officer named Steve Bales had about 15 seconds to make the call. He said, "Go." It turned out the computer was overloaded with radar data, but it was prioritizing the important stuff correctly. The landing continued. Armstrong took manual control because the original landing site was full of boulders. He flew the lunar module sideways, looking for a flat spot, while a fuel warning light was blinking. By the time the landing legs touched down, they had about 20 seconds of fuel left. 20 seconds between the most famous moment in human history and a catastrophic abort. And here's the thing nobody mentions. Buzz Aldrin took communion on the moon, like full Christian communion with wafer and wine that he brought with him. He poured wine into a small chalice in the lunar module before they stepped out. He kept it private at the time because NASA was already dealing with a lawsuit from Madalyn Murray O'Hair over the Apollo 8 crew, reading from Genesis. But yeah, the first thing humans consumed on another world was sacramental wine. Armstrong stepped out first. He fluffed his line, by the way. He meant to say, "One small step for a man, one giant leap for mankind." The A got dropped, either by him misspeaking or by static. Without the A, the sentence kind of doesn't make sense because man and mankind mean the same thing. He insisted for years that he said it correctly. Audio analysis has gone back and forth. They spent about 2.5 hours on the surface, collected 47.5 pounds of moon rocks, planted a flag, took photos, left a plaque that read, "We came in peace for all mankind." And then they got back in the lunar module and launched off the moon, hoping desperately that the engine would actually fire, because if it didn't, they were going to die on the moon, and Nixon had a speech prepared for that scenario. It's a real document. You can read it. It's called "In Event of Moon Disaster." The engine fired. They made it home. And humanity had officially reached another world. But here's what most people don't realize. After Apollo 11, we went back 5 more times, and the missions kept getting weirder. By Apollo 17, Astronauts were driving rovers around, hammering core samples out of ancient lava beds, and one of them, Alan Shepard, was hitting golf balls. Yeah, the first person to play golf on another world wasn't a stunt by some billionaire. It was a 47-year-old Navy admiral with a smuggled 6-iron head he attached to a sample collection tool. He hit 2 balls. Claimed one went miles and miles. It probably went about 200 yards, but in 1/6 gravity with a suit that barely let him swing, that's pretty respectable. And then we just stopped going. December 14th, 1972. Eugene Cernan steps off the lunar surface for the last time. He was the commander of Apollo 17. Before he climbed up the ladder, he said, "We leave as we came, and God willing, as we shall return, with peace and hope for all mankind." That was over 50 years ago. Nobody has been back since, and the question of why is, in my opinion, the most uncomfortable question in the entire space program. Because the answer isn't what you've been told. Let me see how to put this. The official narrative is that the Apollo program ended because of budget cuts and shifting priorities. And that's partially true. Vietnam was draining the federal budget. The economy was in trouble. Public interest had faded. By Apollo 13, the networks were barely covering the missions until the explosion turned it into a survival story. By Apollo 17, most Americans couldn't have named the crew. But there's another layer to it. Apollo wasn't really about exploration. It was a Cold War flex. Once the US had beaten the Soviets to the moon, the political reason for going was gone. Nobody in Congress wanted to keep spending Apollo-era money on something that didn't have a clear strategic payoff. So they killed it. NASA had planned Apollo missions 18, 19, and 20. Those astronauts had been training. Hardware had been built. Apollo 18 was supposed to land in Schrödinger crater on the far side. Apollo 20 was supposed to land in Copernicus crater. The hardware that would have flown those missions ended up in museums. You can go see the unflown Saturn V rockets today. They're just sitting there. Monuments to a future we decided not to have. Here's the deal. After Apollo, we essentially gave up on going beyond low Earth orbit for 50 years. The space shuttle, for all its accomplishments, never went anywhere. It just went up about 250 miles and came back down. The International Space Station orbits at roughly the same altitude. We had the technology to go to the moon in 1969. We had the will. And then we just stopped for half a century. If you want a depressing thought, the people who walked on the moon are dying. As of right now, only 4 of the 12 moonwalkers are still alive. Buzz Aldrin, David Scott, Charles Duke, and Harrison Schmitt, and they're all in their 90s. There's a real possibility that within the next decade, every human being who has ever set foot on another world will be gone. And we'll still be stuck on Earth looking up, unless something changes. And as it turns out, something is changing. Fast. The next chapter of lunar exploration is already underway, and it's going to make Apollo look quaint by comparison, because what's coming isn't a flag-planting visit, it's a settlement, a permanent human presence. And the people behind it aren't just governments, they're kind of a wild cast of characters that nobody saw coming 20 years ago. But before we get to the future, we need to talk about what the moon actually is. Because if you're going to live there, mine there, or build infrastructure there, you need to understand the environment. And the moon is, for lack of a better term, a hellscape. A beautiful hellscape, but a hellscape nonetheless. Let me think about how to describe the moon's environment without making it sound like I'm trying to scare you off ever going there. Although, honestly, if this section scares you off, that's probably reasonable. The moon has no atmosphere. Well, technically, it has an extremely thin atmosphere called an exosphere, but the density is so low that the particles basically never collide with each other. For comparison, Earth's atmosphere has roughly 10 to the 25th molecules per cubic meter at sea level. The moon's exosphere has about 10 to the fifth. That's a difference of 20 orders of magnitude. The moon's atmosphere is closer to vacuum than to Earth's air. What does that mean practically? It means there's no air to breathe, obviously, but it also means there's no air to slow down anything. So if a tiny micrometeorite hits the moon at 20 kilometers per second, which is normal cosmic speed, it just slams into the surface at full speed. Earth's atmosphere burns up most micrometeorites before they hit the ground. The moon doesn't get that luxury. It also means no protection from radiation. Earth's atmosphere absorbs most of the harmful radiation from the sun. The moon gets the full dose. Solar flares, cosmic rays, the works. An astronaut on the moon's surface gets about 200 times more radiation than someone on Earth. Living there long term without serious shielding would be like a one-way ticket to cancer. Temperature is also a problem. Because there's no atmosphere to retain heat, the temperature swings are insane. In direct sunlight, the lunar surface can reach 127 degrees Celsius. In the shadow, it drops to negative 173 degrees Celsius. That's a 300-degree swing. And it happens at the line between sunlight and shadow. You can have one foot in 127 degrees and the other in negative 173. The lunar day, by the way, is about 29.5 Earth days long. So you get roughly 2 weeks of scorching sunlight followed by 2 weeks of bone-shattering darkness. There's also dust. And I cannot overstate how big a problem lunar dust is. Apollo astronauts hated it. Hated it. Lunar dust, called regolith, is made of microscopic glass shards. Because there's no weather on the moon, no wind, no water, the dust doesn't get smoothed down the way sand does on Earth. Every particle is jagged, sharp, and electrostatically charged. The astronauts brought it back into the lunar module on their suits. It got everywhere. It clogged seals. It scratched their visors. It tore up their gloves. Harrison Schmitt on Apollo 17 developed something called lunar hay fever when the dust got into the cabin air. His eyes watered, his throat closed up, his skin itched. And here's the scary part. We don't know what long-term exposure to lunar dust would do to a human. The longest anyone has been exposed is about 3 days. If you're planning to live on the moon for years, that dust problem becomes existential. Gene Cernan, the last man on the moon, said this about dust. I think dust is probably one of our greatest inhibitors to a nominal operation on the moon. He said it could freeze up apparatus, prevent it from operating. This is from a guy who actually had to deal with it. He wasn't being dramatic. Here's an obscure fact for you. Lunar dust smells. Or more accurately, it smells when you bring it into a pressurized environment. Apollo astronauts consistently describe the smell as similar to gunpowder. Spent gunpowder specifically. Nobody knows exactly why. The most popular theory is that when the dust gets exposed to oxygen for the first time in billions of years, it undergoes a rapid oxidation reaction that releases that gunpowderish smell. The actual chemistry is still debated. But yeah, the moon smells like a fired gun. Then there's gravity. The moon has about 1/6 the gravity of Earth. Which sounds fun, and it kind of is. You could jump 6 times higher, lift 6 times more weight, all that. But long-term low gravity does weird things to the human body. astronauts on the International Space Station in microgravity lose bone density at about 1% per month. We don't know what 1/6 gravity does over years. It's probably better than microgravity, but it's almost certainly worse than full Earth gravity. And here's the really weird thing about gravity. Some scientists are worried about what 1/6 gravity does to a developing fetus. Like, can you even have a healthy human baby on the moon? Nobody knows. The first generation of moon kids would basically be a giant biological experiment. Their bones would develop differently. Their cardiovascular systems would adapt to low gravity. If they ever came back to Earth, they might not even be able to stand up. We're talking about potentially creating a separate human population that's biologically incapable of returning to its home planet. Heavy stuff. Anyway, the moon also has these weird geological features that nobody really knew about until recently. There are lava tubes, massive ones. When the moon was geologically active billions of years ago, magma flowed under the surface in channels. When the Theia magma drained out, it left behind hollow tubes. Some of these tubes are huge. We're talking potentially hundreds of meters across and kilometers long. On Earth, lava tubes can be a few meters wide. On the moon, because of the lower gravity, they can be enormous. And here's why this matters. Lava tubes are the most likely candidate for permanent moon bases. Inside a lava tube, you're protected from radiation. You're protected from micrometeorites. The temperature is stable, hovering around -20 degrees Celsius, which sounds bad but is actually 1,000 times more manageable than a 300-degree swing. You don't have to build a shelter. You just have to seal off a section and pressurize it. In 2009, a Japanese probe called Kaguya discovered a skylight in an area called Marius Hills. It's a hole in the surface that drops down into what scientists think is a massive lava tube. The opening is about 65 meters wide. The tube itself might extend for kilometers. NASA has identified at least 200 similar pits scattered across the moon. Any one of them could be the entrance to humanity's first off-world city. By the way, this is one of those facts that I think doesn't get enough attention. We're not going to build moon colonies on the surface, exposed to radiation and meteorites. We're going to build them underground, or more accurately, inside pre-existing caves that the moon already provides. The moon is basically offering us free real estate. We just have to move in. Then there's water, which, for most of the 20th century, scientists were convinced didn't exist on the moon. The Apollo samples were bone dry. No water at all. The moon was assumed to be a dead, dry rock. But in 1994, a probe called Clementine detected something weird at the lunar poles. Radar signals suggested there might be ice in the permanently shadowed craters, places that the sun never reaches, where the temperature stays below -240 degrees Celsius forever. Cold enough that any water vapor that drifted in over billions of years would freeze and stay frozen. In 2009, NASA literally crashed a probe into one of these craters called Cabeus near the South Pole. The crash kicked up a plume of debris, and in that plume, instruments detected water. A lot of water. Recent estimates suggest there could be hundreds of millions of tons of water ice at the lunar poles, maybe billions. Why does this matter? Because water is the most important resource in space. You can drink it, you can split it into hydrogen and oxygen to breathe. You can use the hydrogen as rocket fuel. You can use the oxygen as oxidizer for that fuel. Water is, for all intents and purposes, the foundation of any permanent human presence in space, and the moon has water at its poles, in permanent shadow, just sitting there, waiting. So we've got a moon with caves you can live in, water you can drink and use as fuel, and 1/6 gravity that makes it the perfect launching point for missions further into the solar system. From an engineering standpoint, the moon is the perfect first step, which brings us to the next chapter, because the people who figured this out aren't sitting around, they're moving fast. And the lunar economy that's about to emerge is going to be, in my opinion, the biggest economic shift since the internet. Let me think about how to even introduce this because it's kind of insane. So here's the thing. There's a new space race happening right now, and the players aren't who you'd expect. In 2017, the Trump administration signed Space Policy Directive 1, officially redirecting NASA's focus back to the moon. The program is called Artemis. It's named after Apollo's twin sister in Greek mythology, which is kind of clever. The goal is to land humans on the moon again, including the first woman and the first person of color, and to establish a sustainable lunar presence by the end of the decade. That's the public-facing pitch anyway. The real story is more complicated. China has its own lunar program. As I mentioned earlier, it's called Chang'e. They've already landed multiple robotic missions, including the first ever soft landing on the far side of the moon in 2019, Chang'e 4. They had to send a relay satellite up to a special orbital point first, just to be able to communicate with the lander. Because, the far side can't directly talk to Earth. The Chinese were the first to figure out that whole logistical puzzle. In 2020, Chang'e 5 returned lunar samples to Earth, the first new samples since the Soviet Luna 24 missions in 1976, 44 years between sample returns. In 2024, Chang'e 6 returned the first ever samples from the far side. China has announced plans for a permanent lunar research station by the 2030s in partnership with Russia. So you've got NASA pushing Artemis, China and Russia building their own base. And then there's the wild card, the private sector. SpaceX, run by Elon Musk, has been awarded the contract to build the lunar lander for the Artemis program. The vehicle they're developing is called Starship HLS. It's a modified version of the same Starship that's being designed to go to Mars. If it works, Starship will be the most capable spacecraft ever built, fully reusable, capable of landing on the moon, refueling, and taking off again. The vision is to drop down 100 tons of cargo on a single landing. For context, the Apollo lunar module landed with about 2 astronauts and maybe a few hundred pounds of equipment. Starship is talking about an order of magnitude more capability per mission. If Musk hits even half his projected timeline, the moon is about to get very, very busy. Blue Origin, run by Jeff Bezos, is also building a lunar lander. Theirs is called Blue Moon. It got a contract from NASA in 2023 to serve as a second option alongside SpaceX. The idea is that having 2 competing systems creates redundancy. If one fails, the other can pick up the slack. Then you've got smaller players. Intuitive Machines landed a robotic spacecraft on the moon in February 2024, the first US moon landing since Apollo 17. Yes, it tipped over on landing and only kind of worked, but it landed. They've already announced plans for more missions. Astrobotic, Firefly Aerospace, iSpace from Japan. There are now dozens of private companies actively working on lunar missions. Most of them you've never heard of. But within 5 years, several of them will probably be household names. Here's the deal. The reason all this is happening now, and not, say, in 1985, comes down to one number: the cost per kilogram to launch something into space. In the Apollo era, launching 1 kilogram of mass to low Earth orbit cost roughly $80,000 in modern money. The space shuttle dropped that to about $54,000 per kilogram. SpaceX's Falcon 9 dropped it to about $2,700 per kilogram. And Starship, if it works, is targeting somewhere between $100 and $200 per kilogram. Maybe less. That's a reduction of about 99.9% compared to Apollo. When the cost of doing something drops by 3 orders of magnitude, the number of people willing to do it explodes. That's just basic economics. And that's why the moon is suddenly viable again. Not because the technology dramatically improved. The moon hasn't moved. The orbital mechanics haven't changed. The thing that changed is that launching stuff into space got cheap enough for non-superpowers to afford. Here's an obscure fact. The actual budget for Artemis as of right now is roughly $93 billion through 2025. That sounds like a lot. But adjusted for inflation, Apollo cost over $280 billion. Artemis is doing more, with more partners, for less than half the cost. And that's before SpaceX or Blue Origin start undercutting NASA's traditional contractors on launches. The actual economics of going to the moon have flipped. Going to the moon used to be the most expensive thing a country could do. Now, it's something a mid-sized company can be a player in. So you have to ask, what are they all going for? Why is everyone suddenly so interested in a barren rock that we've already been to? 3 things: water, helium-3. And real estate, we talked about water. The lunar poles are the new gold rush. Whoever controls the polar ice deposits controls the rocket fuel supply for the inner solar system. That's an enormous strategic advantage. Once you can refuel on the moon, you can launch missions to Mars, the asteroid belt, anywhere, with a fraction of the propellant you'd need to launch from Earth. The moon becomes the gas station of the solar system. Helium-3 is a different story, and this one is, in my opinion, kind of overhyped in pop science articles. But there's a real grain of truth. Helium-3 is an isotope of helium that's extremely rare on Earth. It's almost non-existent, but it's deposited on the moon's surface by the solar wind, accumulating over billions of years. There's maybe 1 million metric tons of helium-3 in the top few meters of lunar regolith. Why does that matter? Because helium-3 is, theoretically, the perfect fuel for nuclear fusion reactors. The kind of fusion reactors we don't actually have yet. The reactions involving helium-3 produce almost no radioactive waste, which would make fusion power genuinely clean. If we ever crack commercial fusion, helium-3 becomes worth somewhere in the neighborhood of billions of dollars per ton, maybe more. Here's the catch. We don't have fusion reactors. We've been 20 years away from fusion for about 60 years now. So mining helium-3 is kind of a bet on a technology that may never materialize. But if it does materialize, the moon becomes the most economically important real estate in the solar system overnight. Companies are positioning themselves for that possibility. And then there's just real estate, plain old land, locations. The lunar South Pole, for example, has these peaks of eternal light, hills tall enough that the sun never sets on them because the moon's axial tilt is so small that the polar regions get continuous sunlight. There are only a handful of these peaks, maybe 4 or 5 really good ones. Whoever sets up shop on those peaks gets perpetual solar power in a thermally stable location. They're the most valuable real estate on the moon. And here's where it gets politically spicy. There's no clear legal framework for who gets to claim what. The 1967 Outer Space Treaty says no nation can claim sovereignty over the moon or any celestial body. But it doesn't say anything about companies or private property. The treaty was written before private space travel was even imaginable. And the legal scholars who work on this stuff have been arguing for decades about what it actually means. In 2015, the US passed the Commercial Space Launch Competitiveness Act, which says American companies can own anything they mine from celestial bodies. So you can't own the moon, but you can own moon dirt you've dug up. Luxembourg passed a similar law. The UAE has one. Japan has one. Okay, so this is the part of the story that almost nobody talks about, and it's, in my opinion, the single most consequential aspect of the next 50 years of human spaceflight. Not the rockets, not the habitats, not the science, the legal framework, or more accurately, the absence of one. Let me ask you a question. If a SpaceX rover lands on the lunar South Pole tomorrow, drives over to a crater full of water ice, and starts mining it, who owns that ice? Is it SpaceX? Is it the United States? Is it humanity collectively? Is it nobody? The honest answer is nobody knows. And that's not because it's a stupid question, it's because the legal architecture for space was written in 1967, when the only entities going to space were the US and the Soviet Union, and the idea of private companies extracting resources from celestial bodies was like pure science fiction. The lawyers who wrote the treaty literally couldn't imagine the situation we're in right now. So let's actually walk through this, because the legal status of the moon is one of the strangest, most undercooked areas of international law, and it's about to become the most important. It starts with the Outer Space Treaty of 1967, officially called the Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies. Catchy title. The treaty was negotiated at the height of the Cold War, when the US and USSR were locked in a space race, and the international community was justifiably terrified that one of them was about to plant a flag on the moon and claim it as sovereign territory. The treaty has been signed by 114 countries, including every major spacefaring nation. It's considered the foundation of international space law, and it's kind of deeply ambiguous when you actually read it. The key provision is Article 2. Let me quote it directly because the exact wording matters here. Outer space, including the moon and other celestial bodies, is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means. Sounds clear, right? Nobody can claim the moon. Case closed, except no. Read it again. National appropriation. National. The treaty explicitly prohibits nations from claiming celestial bodies. It says nothing about private companies. It says nothing about individuals. It says nothing about international consortiums. It just says countries can't do it. This is what lawyers call a drafting gap. And it's not an accident. The treaty was negotiated between governments by governments about governments. The idea that a private corporation might land on the moon was so far outside the Overton window of 1967 that nobody bothered to address it. Now there's a counter-argument. Article 6 of the treaty says that nations are responsible for the activities of their non-governmental entities in space. So if SpaceX does something on the moon, the US government is legally responsible for it. The argument goes, if a US company claimed sovereignty over a piece of the moon, that would effectively be the US claiming it, which would violate Article 2. But claiming sovereignty and owning property are different concepts. This is like a fundamental distinction in law. Sovereignty means the right to govern a territory, enforce laws, control borders. Property ownership means you have rights to use, sell, or develop a specific piece of land. You can own a house in France without France being sovereign to you. You can own property in a country without governing it. So the question becomes, can a private company own property on the moon without their government claiming sovereignty over it? Some lawyers say yes. Some say no. Some say it depends on what kind of property and what kind of use. The treaty doesn't answer the question because the question wasn't being asked when the treaty was written. Now here's where it gets actually wild. There's a second treaty, one that almost nobody knows about. It's called the Moon Agreement of 1979. Full name: Agreement Governing the Activities of States on the Moon and Other Celestial Bodies. The Moon Agreement was an attempt to fix the ambiguity of the Outer Space Treaty. It explicitly declares the Moon and its natural resources to be the common heritage of mankind. It says that no nation, organization, or person can claim ownership of any part of the Moon or its resources. It calls for an international regime to govern lunar resource extraction, with benefits shared among all countries, particularly developing nations. Sounds reasonable, right? Equitable. Forward-thinking. Here's the thing, almost nobody signed it. The Moon Agreement has been ratified by 18 countries. 0 of them are major spacefaring nations. Not the US, not Russia, not China, not Japan, not India, not the UK. The signatories include Australia, Austria, Belgium, Chile, Kazakhstan, Lebanon, Mexico, Morocco, the Netherlands, Pakistan, Peru, the Philippines, Saudi Arabia, Turkey, Uruguay, and Venezuela. France signed but never ratified. India signed but never ratified. So the treaty exists. It's technically in force. But it's been deliberately ignored by every country that actually has the capability to go to the moon, which is kind of an incredible diplomatic statement. The major space powers looked at the Moon Agreement, said, no thanks, and walked away. Why? Because the common heritage of mankind framework would have made commercial lunar activity essentially impossible. If you mine water ice from the moon and you have to share the proceeds with 195 countries, what's the economic incentive to invest billions of dollars in the mining infrastructure? There is none. The Moon Agreement, if widely adopted, would have frozen the moon as an international preserve. The spacefaring nations weren't willing to do that. So now we have 2 treaties, one that everybody signed but doesn't address private property, and one that addresses private property but nobody important signed. This is like the worst possible legal situation. China doesn't really care about any of these laws. Neither does Russia. So we're heading into a situation where multiple major powers are about to start extracting resources from the moon, and there's no agreed upon system for who gets what, or what happens when disputes arise. In my opinion, this is going to be the central drama of the next 30 years of space history. Not the technological challenges, those are solvable. The political and legal challenges of dividing up a new world among competing nations and corporations. That's the part that's actually going to be messy. Anyway, let me get back to the human side of this, because what's coming isn't just resource extraction, it's people living on the moon permanently. And what that life looks like is genuinely strange. Picture waking up. You're in a habitat module buried inside a lava tube about 50 meters below the lunar surface. There's no window. There can't be a window. Windows are weak points in pressurized environments. Instead, there's a screen on the wall showing whatever you want. Maybe a beach, maybe a forest, maybe just the actual view from a camera on the surface above. You're in 1/6 gravity, so getting out of bed is kind of an art form. If you push too hard, you launch yourself across the room. Astronauts who have spent time in low gravity say it takes weeks to learn how to move efficiently. Your brain is wired for Earth gravity. Unwiring that takes time. You're hungry. Breakfast is, depending on the year, either rehydrated, freeze-dried meals or something from a 3D food printer, or, if you're lucky and the colony has been there long enough, something grown in a hydroponic garden. Probably greens, lettuce, kale, tomatoes, stuff that grows fast in artificial light. No coffee because coffee plants are too inefficient for the space they take up. Tea, maybe, if the garden has been expanded. You suit up to go to work. Suiting up takes about an hour, even with the new generation suits being designed for Artemis. You step into an airlock. The atmosphere cycles out. The outer door opens, and you walk onto the surface of the moon. The sky is black, always black, because there's no atmosphere to scatter light. Stars are visible even in direct sunlight. The Earth is hanging in the sky, depending on your location, either always visible or never visible. If you're on the near side, you can see Earth. If you're on the far side, you cannot. Some people who study the psychology of long-duration spaceflight think living on the far side might cause unique psychological problems just from not being able to see home. The horizon is close, really close. Because the moon is smaller than Earth, the horizon is only about 2.4 kilometers away if you're standing at average height. On Earth, it's about 5 kilometers. So the world feels smaller. Everything curves away faster. You drive a pressurized rover to the mining site. The rover has tracks instead of wheels because the regolith is too loose and abrasive for normal tires. The mining operation is extracting water ice from a permanently shadowed crater. The ice gets sublimated, captured, and split into hydrogen and oxygen. The hydrogen goes into fuel tanks for return missions to Earth or onward missions to Mars. The oxygen goes into life support or fuel oxidizer. The work is dangerous. Lunar dust is corrosive. The radiation environment is brutal. Solar flares can produce dangerous radiation spikes with only a few hours warning. If a flare hits while you're outside, you have to get to shelter immediately. Real shelter with thick walls and water tanks to absorb the radiation. People who don't make it in time can develop acute radiation sickness within hours. This isn't science fiction, by the way. This is what NASA, China, and several private companies are actively planning. The first permanent lunar habitats are projected for the early 2030s, within 10 years. Let me think about who would actually do this job. Who signs up to live on the moon? And I think the answer is kind of a specific personality type. You'd have to be willing to live in a 50 square meter habitat for years at a time. You'd have to be okay with the same 6 or 8 people being your entire social circle. You'd have to accept that your bones are slowly demineralizing, your eyes might be developing pressure issues from the low gravity, and you might never be able to come back to Earth. The early settlers of America had it bad. The early colonists of Australia had it bad. Both of those groups would have looked at moon settlers and said, yeah, no thank you. Here's a personal aside that I think is relevant. When I read about all this, I kind of want to go. There's a romantic pull to the idea of being on a new world, of being part of the first generation to leave Earth. But then I think about like missing my family, missing rain, missing trees, missing the smell of fresh bread, missing the feeling of sun on bare skin without 17 layers of protective clothing between you and the universe. And I think, no, actually, I'd probably last about 3 months before I had a mental breakdown. This is going to be one of the most interesting filters in human history. The kind of person who thrives in a lunar colony is going to be a very specific kind of person. They're going to be a self selecting group, and the culture that emerges from lunar colonies is going to be genuinely different from anything that's existed on Earth. By the way, here's another fact that doesn't get enough attention. Communication delay between Earth and the Moon is about 1.3 seconds each way. So a conversation has a 2.6-second lag. That's annoying but workable. Compare that to Mars, where the lag is anywhere from 4 to 24 minutes each way. Mars colonists will essentially be cut off from real-time communication with Earth. Lunar colonists won't. They'll be close enough to feel connected, far enough away to be alone. It's a weird liminal distance. The economics of lunar colonization are also interesting. The current cost estimate for a small permanent base supporting maybe 4 to 6 people is somewhere around $35 to $50 billion. That's expensive, but it's not crazy expensive. The US spent about $90 billion on the F-35 fighter jet program. We have an aircraft carrier that cost $13 billion to build. The math in raw numbers kind of works. The first generation of lunar colonies will be research outposts, like Antarctic research stations but in space. The second generation will be commercial operations, mining, manufacturing, fuel production. The third generation, if we get there, will be something genuinely new. Permanent settlements where people are born, live, and die without ever seeing Earth. That third generation is like 50 years away minimum. But it's coming, and the cultural implications are going to be massive. The first child born on the moon will probably be born in our lifetimes. Think about that. A human being who has never felt Earth gravity, whose entire experience of the world is small habitats and gray landscapes and a blue marble hanging in a black sky. That's a person who's going to grow up with a fundamentally different relationship to humanity than the rest of us. And here's where I want to plant another open loop, because the long-term future of the moon is, in my opinion, the most fascinating part of this whole story. Some scientists think the moon won't just be a research outpost or a mining colony. Some think it could eventually host the most important scientific instrument ever built. And the location for that instrument? The far side, the one place in the entire solar system where you can actually do this kind of science. I'll explain, but first, let me get to something I keep dancing around. Because we can't talk about the moon's future without talking about the conspiracy theories that surround its past. Yeah, we're going there. I want to be careful with this section because I don't want to give oxygen to nonsense. But also, I think it's important to address head-on. Because a non-trivial percentage of people, somewhere between 5 and 20%, depending on the country, believe the moon landings were faked. Let me just say this clearly. They weren't. The Apollo missions happened. We have hundreds of thousands of pages of documentation. We have telemetry data. We have photographs that have been verified by every major space agency in the world. We have moon rocks that have been studied by thousands of scientists in dozens of countries. We have retroreflectors on the lunar surface that scientists still bounce lasers off of today, including from Chinese facilities. If the landings were faked, the Soviet Union would have been the first to call it out. They were tracking the missions. They had every motivation in the world to expose a hoax. They didn't, because there was no hoax. The conspiracy theory got started by a guy named Bill Kaysing, who self-published a book in 1976 called "We Never Went to the Moon." He had worked for a NASA contractor, but his actual job was as a technical writer. He had no engineering background. His evidence was almost entirely based on misunderstandings of basic physics. Like he didn't understand why the flag appeared to wave, even though it was just rippling from the way they planted it and the lack of atmospheric damping. He didn't understand why there were no stars in the photographs, even though that's basic photography. The cameras were set for daylight exposure. Stars don't show up at daylight exposure settings. They don't show up in pictures from the International Space Station either. But Kaysing's book got popular, and then in 2001, Fox aired a documentary called Conspiracy Theory: Did We Land on the Moon?, which repackaged Kaysing's nonsense for a TV audience. After that, the idea entered the cultural mainstream. The actual reason I bring this up isn't to debunk it point by point. There are entire websites dedicated to that. The reason I bring it up is because I think it tells us something interesting about how humans process big events. When something genuinely transformative happens, like landing on another world for the first time, a portion of humanity refuses to believe it. They invent alternative explanations. They construct elaborate theories. Some of this is, basic distrust of institutions. Some of it is, in my opinion, just a kind of psychological inability to accept that the world has fundamentally changed. And here's the thing, as we move into a new era of lunar exploration, this is going to happen again. When SpaceX or Blue Origin or China lands people on the moon, in the 2030s, there will be people claiming it's fake. There will be elaborate YouTube videos explaining why. There will be politicians who echo those claims for political reasons. We've been through this before. We'll go through it again. Anyway, let me get back to the actual story, because there's one more chapter of lunar history that I haven't covered yet, and it's like the most ambitious thing humans have ever proposed. The far side of the moon as a scientific instrument. So here's the deal. As I mentioned earlier, the far side of the moon is the radio quietest place anywhere near Earth. No Earth signals can reach it directly. The moon's body blocks all of our broadcasts, our satellites, our Wi-Fi, our cellular networks, all of it. That makes the far side the perfect location for a specific kind of telescope, a radio telescope sensitive to the longest wavelengths of light in the universe, wavelengths that get blocked or distorted by Earth's atmosphere and ionosphere, wavelengths that come from basically the beginning of time. There's a period in cosmic history called the Dark Ages. It's the time between when the universe became transparent, about 380,000 years after the Big Bang, and when the first stars formed, about 100 million years later. During those dark ages, the universe was full of hydrogen gas, but no light sources, just darkness. We've never been able to observe this period directly. We can see the cosmic microwave background, which is from before the Dark Ages, and we can see the first galaxies, which are from after. But the Dark Ages themselves have been invisible to us. The hydrogen gas during that period emitted radio waves at a specific wavelength. Today, after billions of years of cosmic expansion, those wavelengths have stretched out to about 10 to 100 meters. That's longer than any radio telescope on Earth can really see, because Earth's ionosphere blocks those wavelengths. But on the far side of the moon, with no atmosphere and no Earth interference, you could build an array of radio antennas that could see the Dark Ages directly. We could potentially watch the universe come out of its dark phase and the first stars ignite. We could see the very first chapter of cosmic history. NASA has actually been studying this. There's a proposed mission called the Lunar Crater Radio Telescope. The idea is to use a crater on the far side as the dish for a radio telescope. The natural curve of the crater would form the parabolic reflector, Wire mesh would be deployed across the crater to act as the actual antenna surface. The receiver would be suspended above the crater on cables. If built, this telescope could be the largest single aperture radio telescope ever made, like kilometers across. It could observe wavelengths that no other telescope can see. It could rewrite our understanding of cosmology. Will it actually get built? Honestly, I don't know. It's the kind of project that's at the absolute edge of what's feasible, probably decades away. But the fact that we're seriously discussing it is kind of indicative of where we are right now. We're moving from going to the moon to using the moon. The moon in this future isn't just a destination, it's a platform, a foundation, a piece of infrastructure that enables everything else humanity wants to do in space. Going to Mars from the moon is much easier than going to Mars from Earth, because you don't have to fight Earth's gravity well. The moon becomes the hub. Earth becomes one of the spokes. And here's the thing that I keep coming back to. The story of the moon, from formation to colonies, is really a story about us, about humans, about this weird, ambitious, often self-destructive species that somehow figured out in less than 100 years how to leave the planet we were born on. For 99.99% of human history, the moon was a mystery, a god, a symbol, something to look up at and wonder. For the last 60 years, it's been a place we've visited but mostly ignored. For the next 60 years, it's going to be probably the center of human civilization's expansion off Earth. Here's a thought that I find like genuinely moving when I sit with it. Every single human who has ever lived, from the first Homo sapiens hundreds of thousands of years ago until very recently, looked up at the same moon, the same craters, the same dark patches, the same phases. The moon is one of the very few things in our universe that's been a stable companion for the entire history of our species. And in the next century, that's going to change. The moon is going to stop being just a thing in the sky and start being a thing humans live on. The next generation of children, if they grow up on the moon, will look up at the sky and see Earth where the moon used to be. They'll have a different relationship to home than any human in history. That's a strange thing to think about. A new chapter for our species, a new branch of the human family, people who, by the time they're old, will have a kind of homesickness for a planet they've never visited. I don't know how to feel about that, honestly. Part of me thinks it's like the most beautiful thing humans could possibly do. Spread out, become a multi-planet species. Make sure that whatever happens to Earth, humanity continues. Another part of me thinks we're maybe getting ahead of ourselves. We can't even take care of the planet we already have. Adding another one to the list of places we're responsible for seems ambitious. But honestly, this isn't really my call, or yours. The decisions are being made right now by space agencies and corporations and politicians and engineers. The first human to live and die on the moon is probably already alive. They might be a kid right now, looking up at the night sky, not knowing what's coming. Within the next century, there will be people who consider the moon home, who feel about Earth the way we feel about ancestral villages we've never visited, a place our great-grandparents came from, a place we know from stories and pictures, a place we feel connected to, but not connected enough to ever go back. That's coming. Maybe not in the next 20 years, maybe not in our lifetimes, but it's coming. The moon is going to become a place where humans are from, not just a place we go. Let me try to wrap this up because we've covered a lot of ground. And honestly, every time I think about the moon, I find another rabbit hole I want to go down. There's just so much there. Here's what I want you to take away from all this. The moon isn't just a rock in the sky. It's the reason Earth is habitable. It's the reason your tides exist, your seasons are stable, your days are 24 hours long. It's the reason life evolved the way it did. Every breath you take is, in a small way, made possible by that one cosmic collision 4.5 billion years ago that created the moon in the first place. It's also the most important destination in human spaceflight, not because it's the most interesting place. It's not. Mars is more interesting. Europa is more interesting. The moons of Saturn are more interesting. The moon is important because it's close, it's reachable, and it has the resources we need to go further. It's the on-ramp to the solar system, and it's about to get crowded. By the 2030s, there will probably be permanent human habitation on the moon. Multiple bases, multiple countries, multiple corporations. The lunar economy will be a real thing. People will have jobs that are based on the moon. They'll commute, in a sense, to lunar orbit and back. The idea of the moon as a remote, untouched wilderness will end. Forever. That's kind of sad. There's something to be said for keeping the moon as it is. A pristine, ancient world that hasn't changed in billions of years. Once we start mining it and building on it, we change it. We damage it. The footprints of the Apollo astronauts will be there for millions of years because there's no weather to erase them. The damage we do in the next century will be permanent on a timescale that's hard to even comprehend. But this is, in my opinion, just what humans do. We move into spaces. We build. We change things. The moon is the next frontier, and frontiers don't stay frontiers forever. They become places with histories and politics and cultures and conflicts. The moon is about to start being a place. The moon is moving away from Earth at about 3.8 centimeters per year. We measure this using the retroreflectors that the Apollo astronauts left on the surface. Scientists bounce laser pulses off them and time how long it takes for the light to come back. The precision is like millimeter level. Over a year, the round trip distance gets about 7.6 centimeters longer. That's how we know the moon is receding. In about 600 million years, the moon will be far enough away that total solar eclipses will no longer be possible. The moon will appear too small to fully cover the sun. Right now, we live in the brief cosmic window where the sun and moon appear almost exactly the same size in the sky, despite the sun being 400 times larger and 400 times farther away. That coincidence is the reason eclipses look the way they do. It's a temporary phenomenon. Future generations of humans, if we're still around, will only see partial eclipses. That's kind of poetic. There's a piece of art on the moon, like an actual art piece. In 1971, Apollo 15 left behind a small aluminum sculpture called Fallen Astronaut, along with a plaque listing the names of 14 astronauts and cosmonauts who had died in the pursuit of spaceflight. It's still there, probably the only piece of art on another world. There's also a Bible on the moon, multiple Bibles actually. The Apollo Prayer League sent over 100 microfilm Bibles to the moon with various missions. Most of them came back, a few are still there. And here's one that I think is like weirdly touching. The cremated remains of a planetary scientist named Eugene Shoemaker were sent to the moon on the Lunar Prospector mission in 1998. The probe deliberately crashed into a crater near the South Pole at the end of its mission, intentionally depositing his ashes. Shoemaker had been one of the geologists who trained the Apollo astronauts. He dreamed of going to the moon himself. He never got the chance in life. But his ashes are there now. The only human remains on another